Hi, and welcome to episode 22 of my free Java video course. My name is Markus Biel. In this episode, I'm going to talk about the two methods equals and hashcode. This tutorial actually concludes my presentation of all the methods of the Java Lang object class. Equals and hashcode both follow a contract that ties them closely together, which is also why I'm talking about both methods in just one episode. Knowing all the details about these two methods will make you a better programmer today. So get yourself some popcorn and listen carefully. So let's start with the equals method. What does it do? What's it actually useful for? The equals method is used to compare two objects for equality, similar to the equals operator, which is used for primitive values. But before I'm going into much more detail, let's first jump into my IDE and see this in action. Now in my IDE, let's first of all see what do we need the equals method for anyway, because so far we happily used the equal operator and this was working. Let's see this again with two primitive values, I equals 4 and j equals 4. So now I assert with the equals operator that they're both equal. And we get the green bar. All tests passed. Everything is fine. So I equals to j. Now let's do the same thing with strings. Here we have a constant value of hello and another constant value hello, and each is assigned to its own string reference variable. Now we also want to compare these two strings with the equal operator. Let's try this. And tada, this is also working. And I told you string is an object, so as this is working, it seems we don't need the equals method at all. Well, with a string it's a bit tricky actually, because with a string there is some optimization going on in the background for constant values. Because for this constant value there's actually only one, and both variables, they both point to the same object in memory. The variable is stored in a memory area called stack. The object is stored in a memory area called heap, and there's only one. But things get quite differently as soon as I add a new string variable and I say string hello3 is only h, and then I say at runtime hello3 equals to hello3 plus concatenate hello to it, which will be hello at runtime. And just to be sure, let's also print this, that we can see there is really hello in the variable hello3. And then let's assert hello1 equal operator hello3. And this is not working. We get the red bar, nasty. So now they're not equal. But here you can see it printed out hello. So from our expectation it should have been equal. So this is something really tricky with string, and in short, you should not use equal operator on objects, also not on strings. Instead, for strings, there is the equals method. Let's try this. Hello1 equals hello3. And this works. It seems like using that method, they're both equal. Now, let's have a look actually at the method. Here we are in class string, and there is a method equals operating on an object. It says things like, if this equals to the object given, return true. So if it's the same reference, if it's the same object, this is actually a performance optimization. Now it checks that the object is actually a string. This is achieved by the instance of operator, so that we can safely cast the object to a string, and so that we can compare both strings. Interesting thing about instance of, by the way, which not many developers know, or at least not all yet. This also includes a check for null. If an object is null, this will never be a string, will never be true, and will return false. So anyway, without going into further details, there's this while loop, and this compares character by character of both strings, and only if they're completely equal it will return true. So this is how equals was implemented in the class string. But actually I told you the equals method is a method from the class object, and yes it is. Well, it turns out string is also a subclass of object, and the string class overrode the equals method here, so that it works on strings as expected. Okay, so it seems like for strings we can happily use equals, so that we know that a string like hello1 and hello3 is equal. Now how are things with classes that we implement ourselves? Like here I have created a class car with owner Marcus. It is a Porsche, and it has the color silver. So it seems like it has both instances have exactly the same attributes, so I would expect them to be the same car. Now let's first of all try it with the equal operator, like before. And this is false. It's not working. Test failed. Well, of course, because we have two different instances here. Let's try the positive case. Porsche 1 equal operator, my Porsche 1 again, comparing it to itself. So yes, this is working, of course. But it seems like to be able to compare Porsche 1 and Porsche 2, we again need to use the equals method. Let's do this now. Porsche 1. Oh, let's first of all, I wanted Porsche 2 here, but let's also do this. My Porsche 1 equals my Porsche 1. I would expect that to be true. And yes, it is true. My Porsche 1, so it is equal to itself. Now, let's compare my Porsche 1 to my Porsche 2. And let's see if this works. It's not working. We have the nasty red bar. This was so nicely working with a string. Why is it not working with our car? Let's jump to this method again. And you see, we are in the class object, because in our car class we have not overwritten the equals method. So what happens is the original method of the class object is used. And as you can see here internally, what happens is we compare this, which is the object itself, in this case my Porsche 1, we compare it using the equal operator to the object that is coming into the method, which was Porsche 2. And this compares only the reference variables and not the objects. So this is false because we have two different reference variables. What, by the way, is also possible to make this true again, we could assign my Porsche 2 the reference variable of my Porsche 1. which would mean this object is somewhere in memory, no variable is assigned to it, and there is this one object here in this line, and both variables point to it. Let's try this. And see, this works, because now actually we only compare the same object with each other. Like here, this compares the reference variables, which now have the same value. So this would be working, but this is not what we want. So let's remove that. We really want to compare both objects. We want to compare this one with that one. Okay, so let's have a look at the class car. This is a small class I wrote, and it just has a constructor and these attributes for now. And there is no equals method overwritten. So this is what we have to do. Public boolean equals. Now, I want to compare a car. No, this you cannot do. In the class object, there is object. So we have to say object here. And then later on we have to cast it to a car, like we saw in the class string. And then it's always good to add the override annotation so that we make sure we have properly overwritten the method. Now, I mean, this is not a true implementation. I always return false just to see that when I'm in my car test, now I jump there, see it jumps to my overwritten method. Now, of course, when this always returns false, this will also not work, so we will have to implement it. But actually implementing such an equals method is not so easy, and we need some more theory for this before we can continue. So let's first of all jump back to my slides. Before we are able to implement the equals method, we need to come up with a proper design first. Actually, many developers just skip the design phase and simply click on auto-generate. But this may lead to severe bugs or at least to suboptimal performance. Let me show you how you can properly do it. First of all, you have to define what it is in your specific program that makes two car instances equal or unequal. In your program, are two cars equal when they have the same manufacturer, maybe? When they have the same manufacturer in color? Or the same engine? The same number of wheels? The same top speed? The same vehicle identification number, or VIN in short? Based on the knowledge of the business you are working in, you have to decide which fields are identifying and which fields are redundant and not helpful for the equal comparison. Besides, for improved performance, you need to define in which order you want to compare the attributes. Are there any fields that have a high chance to be unequal? Are there fields that may be compared faster than others? To implement a meaningful equals method, you must first analyze all these aspects in great detail. Let's go through this process with my example. I would assume that the car's top speed relates to the type of engine in some form. So that seems to be a redundant field that will not be helpful for the equals implementation. So let's just remove it. Let's just say the number of wheels is always 4 in our specific example. So number of wheels would also not help us to differentiate a car. What about the VIN? Well, this again depends on the type of program you want to create. For a public authority, like the police, This one is probably the only proper way of identification. But what about a program used by the manufacturer itself? While the car is still being built and not sold yet, I would assume the VIN is of less importance. But I personally wouldn't know that in detail. This is what you will have to clarify with the business people of your company or your department. Based on their knowledge, you have to select which attributes to compare in which order. In my artificial example here, I'm the developer as well as the business analyst. So for my example, I just arbitrarily define that two cars with different VIN numbers can be seen as equal. Therefore, I will not include this field in my equals comparison later on. Now before you think, that's it, I'm sorry, there's actually some more theory to cover. In the introduction I already told you that there is a contract of equals in HashCode we have to fulfill. First of all, there are 5 conditions our equals implementation has to comply with. Believe me, it looks much more scary than it actually is. Let's go through each of them slowly. Reflexivity. An object must be equal to itself so that when I call my old car equals my old car, it returns true. I think this makes sense and should be easy to understand. Symmetry. 2 objects must agree whether or not they are equal. If my old car equals some other car, then some other car equals my old car must also return true. This sounds obvious and very simple, when in fact it is not such a simple condition when it comes to inheritance. If you have a car class and a BMW class, which is extending the car class, it could happen that your BMW is equal to a car, but the same car is not equal to the BMW, as every BMW is a car, but not every car is a BMW. So you see, the symmetry rule can actually lead to some nasty problems. There are quite a few interesting articles online discussing potential symmetry issues of the equals method. Cover each contract condition with a dedicated unit test to make sure your class stays fully compliant with the contract. Our next condition is transitivity. If one object is equal to a second and the second is equal to a third, then the first must be equal to the third again. This rule sounds much more complicated than it actually is. If object A is equal to object B and object B is equal to object C, they should all be equal to each other so that C is also equal to A. Consistency. If 2 objects are equal, they must remain equal for all time, unless one of them is changed. So when you repeatedly compare the same 2 objects with the equals method, it should always return the same result. In other words, calling the equals method should not alter the object in any way. The last rule, null returns false, is what Josh Block calls non-nullity. When null is given as a parameter to any equals method, this should always return false and never throw a null pointer exception. So now you know quite a bit about the equals method. But what is the hashcode method actually useful for? For processing, similar objects are usually put into a collection. Such a collection in Java is like a more powerful array, or an array on steroids, as I often call it. Besides other things, it allows you to look up objects not only based on their index position, but also based on their specific values. This is where the equals method comes into play. To speed up this lookup process, the Java creators added specific hash-based containers that will use the hash value as a grouping mechanism to reduce the number of equal comparisons needed. In the optimal case, each object that is considered unequal by the equal method will also return a different hashcode. This hashcode is used to group the objects in so-called buckets. Now in this optimal case, you will be able to find each object simply by a lookup based on its hash value. However, there may also be something called hash collisions, where two unequal objects will share the same hash code, in which case they end up in the same bucket. Now if I'm looking for Dad's car, I have to look up the correct bucket based on the hash code -391 that Dad's car will return. However, as there is a hash collision, I will on top have to do an equals comparison on a list of two cars in this case. A legal but inadmissible bad performing hashcode implementation could statically return 42 for all objects. In this case, however, the whole hashcode logic would not help at all. In the end, you would have to do an equals comparison on the entire list of cars, just as if the hashing logic had never existed. Okay, now that I have talked about the general idea of the hashcode method, I have to further tell you about the contract that the hashcode method has to fulfill. The first condition that has to be fulfilled by the hashcode method is: for any two objects, return same hashcodes when equals returns true. To achieve this, use the same identifying attributes for both methods in the same order. Don't worry too much now if you don't fully understand what I mean. As soon as I'm finished introducing you to the hashcode contract, I will jump back in my IDE and show you a practical example. When hashcode is invoked more than once on the same object, it must consistently return the same int value as long as the object is not changed. This rule is similar to the equals consistency rule I introduced you before. Both equals and hashcode methods must return consistent results. To fulfill this contract, you should override hashcode whenever you override equals and vice versa. Also, when you add or remove attributes from your class, you will most probably also have to adjust your equals and hashcode methods. Last but not least, aim to return different hashcodes when equals returns false. This is not a hard and fast rule, but it will improve the performance of your program by minimizing the number of hash collisions. To the extreme, the hashcode contract would allow to statically return 42 for all objects. As Josh Block states in his book Effective Java, however, this could result in quadratic rather than linear execution time, and therefore could be the difference between working and not working. Actually, the hashcode method is a rather complicated beast. I couldn't practically fit in all the details without risking that you would fall asleep. Therefore, I have done a follow-up tutorial that will give you an in-depth view on the hashcode method, which you will need to understand to become an expert in Java programming. Below this video, there is a link you can click to watch my follow-up tutorial for the hashcode method. For now, that's all the theory. You need to be able to implement your own hashcode and equals methods. To round up this topic, let's jump back into my IDE to show you some practical examples of hashcode and equals methods. So back in my IDE, you can see I've implemented both equals and hashcode based on the fields manufacturer, engine and color. also here in HashCode, manufacturer, engine, and color. So I've implemented them based on the decisions I made during the simulated design phase that I did during the theory session. So the car class has fields like vehicle identification number, manufacturer, engine, color, and number of wheels. But in the design phase, I decided that number of wheels and vehicle identification number are not helpful for the way I want to compare a car. Of course, this is totally arbitrary, so this is not how you would do it. I really can't stress that enough. In your case, in reality, you have to talk to the business people and find out what is important and what is not. Also, totally arbitrary is the order that I have chosen. I just thought about it, and I thought that while there are millions or however many colors, that usually for cars there are not so many colors. I think most cars are either black, white, silver, blue, red. A few might even be green or yellow, but that's probably it. So I thought there are probably more different manufacturers and also more different engines, and I want the equals method. If I compare two objects which are not equal, I want to leave the method as early as possible, because the earlier I leave the method, the faster the entire code will run. If two instances are equal, then usually it has to go till the very end. So in this case it doesn't make a difference, but it does make a difference if it's not equal, if we can leave the method here. So for performance optimization, I have chosen this order. So this is what I would also ask you to do. Think about a good order to improve the performance, and if the performance is important, then you should test it, because you never know for sure until you test for the performance. What is important, that the order is the same in HashCode and Equals. And now we should also talk about all this stuff here on top. This mostly is also a performance optimization. At least here, this equals object. So if I compare the object to itself, I want to directly return true, because then the reference variable references the same object in memory, and so I directly know it's the same object. I don't have to compare all these things. So this is why I have this here. If you have a specific case where you know that you will never ever compare an object to itself, you might even leave this if away. This depends. Generally, this is done because such a check doesn't also cost a lot. Then this object equals null, return false is actually very important here. This is the last rule that we have to fulfill, that when an object that we compare is null, that we always return false, which is also important because otherwise object.getClass would throw a null pointer exception. But this cannot happen because now we have already left the equals method with false. Okay, and then the third if check compares both classes so that we make sure that the object that is coming in to our equals method is also a car, so that we're not comparing bikes and cars, for example, or cars and apples or whatever, right? Because otherwise also this explicit cast to car would also throw a class cast exception. But now that we have made sure that they're both of the car class, we can safely cast the object to a car. And now I think this is quite interesting, because now I can easily say manufacturer equals other dot manufacturer. This field here is private, but because we are here in car, even though this is another instance, but it is also an instance of car, I can directly access this private field. So I don't have to use any method, I can directly access the field. This works and makes the code, I think, much more readable and shorter. So if it's not equal, then I can directly leave the method and say return false. I do this with all the fields, and if I'm here, then I'm sure that all the three fields are equal. So I do not compare number of wheels as well as vehicle identification number, because as I said, about them I don't care, because number of wheels in my specific example would always be 4, so would be the same anyway. And vehicle identification number, there might be 2 different cars, but just like if I'm only interested in the price of a car, for example, or the look, then I wouldn't care that actually they are physically 2 different cars. I would just say, well, this is a BMW with, I don't know, that kind of engine in blue. So for me, this is the same car, period. Yeah. Okay, so that much for the equals method. Now the hashcode method. This is actually very complicated, I'm sorry. And it's so complicated that I've decided to do a follow-up tutorial, as said before, which I really recommend you to watch. There is a link below this video. You can click to watch the follow-up. So here only in short about the hashcode method. The 31 here is a prime number, and a prime number here is multiplied with always the result. So this continues to take the hashcode of a field, which will return some int number. We'll add it starting with 1 and then multiply it with 31, and this for each attribute. The reason is this is an optimization to have less collisions, because I told you about the collisions, that this can decrease the performance. As you see, I'm actually not really doing something here. I'm just calling recursively the hashcode for each class. And this is why now we should jump in the other classes. At least I can't show you all the classes, but I've chosen engine here in this case to see how it's actually hashcode implemented in one example. So let's jump to engine. Okay, so the equals method is pretty much the same, or at least similar, than in car. The only difference is here I added something that I called optional field, because I defined that this optional field could also be null. So therefore, my check here for equals has to be a bit more complicated, because I have to say if it's null, then I check if the other field is also null. If it's not null, then this field is null, the other is not, so it's not equal. And if it's not null, then I can compare both fields. So I'm doing all this again to prevent a null pointer exception. In the other case, when I don't check for null, my assumption is that, well, this is a primitive field, so it can't be null anyway, but for car, my assumption was that a car always needs a manufacturer, an engine, and a color. So my assumption is those fields will never be null. If someone would introduce a bug and would forget to set these fields, then of course this could produce a null pointer exception, but checking for something that is exceptional, this is what I call rocket code, because it is like extra safe code. This is just cluttering your code. You have to have certain assumptions, like saying my design forbids that these fields can never be null, and so I trust on that. Otherwise, well, the program will crash. Okay, we have to fix it, but then the problem is already fixed and the code stays clean. And this is important because your code should be really readable and maintainable. Okay, so only for fields where you know they can be null, add these extra null checks. Okay, so that much for the equals method. Everything else here should be the same as in car. Now for the hashcode method, here you see there is some more stuff going on, because here I cannot forward to a hashcode method, but instead I have here a primitive long. And because the primitive fields there, you actually have to calculate some hashcode. And this is a long, and so we want to convert a long to an int. A long has 64 bits, while an int has only 32 bits. So you want to make the long to half its size, and you want to make it in a way that will result in the least possible number of collisions. And therefore this weird line here, this here does it. This is actually based on, again, Josh Block's book Effective Java. There he explains it. Well, actually he doesn't explain it too much. If you want an in-depth explanation, again, watch my follow-up tutorial about hashcode. There I can explain you. Now here only in short, this is a shift by 32 bits, and then this is an XOR, where you again let's say combine this field, and last but not least you do an explicit cast from long to int, where you throw away half of the long. But this whole thing I can't explain you in 1 minute. You have to watch really the extended tutorial, but this is really a very performant, good way to create an int hashcode from a long. This is the standard default way of how this is done today. And the second field here is a string. As it can be null, I need this extra null check, and I'm not sure if I have shown you this before. This is like an if. It's just shorter because otherwise the code would even be longer. So you have to read it as is optional field null? If true, then return 0, else return optional field dot hashcode. So this again calls the hashcode method of string. This I showed you in the beginning of this episode, where the code was in a while loop going over each character of the string and then calculating an int value for the string. So as this is already done for us, we can simply call the hashcode method. Okay, so again, you also see I have in this case two fields, and in this case I decided to use both to differentiate if an engine is equal or not. And so as I use type and optional field in equals, again I use type and optional field in hashcode in the same order and same fields. Okay, last but not least, sum class. Now this doesn't mean anything. This is really totally abstract. I just wanted to, in very short, show you all the different primitive types there are, plus the string object, so that you see how the different cases of equals and hashcode could be calculated. So let's first of all look at hashcode. So this with long we have already seen. Same one here. Float. Well, float has the same size, 32 bits, like an int, and then there is a native function which will convert the float to an int to be used for the hash code. Double has the same length as a long, so this is done in 2 steps. First of all, it's converted again with a native function to long. A native function is a function that is not implemented in Java, but in machine-dependent code. So I can't show you. But again, for details, watch my follow-up tutorial. But anyway, so the long we take, and again we do this weird line here to convert it to an int. Next one, Boolean. Here again, this weird stuff here. If it's true, question mark, then 1231. And if it's not true, then take this number. All this stuff is really technical, might be a bit hard for you to understand. This is just really important for performance optimization to have the least number of collisions. Car is just taken as it is because it can be handled like a number. For string again, we call this hashcode method. And for the other fields, everything that is as big as an int or smaller than an int, that's relatively easy because you can just take the value as it is, because a byte will always fit into an int, a short will always fit into an int, and an int, of course, should also fit into an int. Okay. So I know this was really rough, really short. It's just not enough time to go in more details, but exactly for this reason, I have done the follow-up tutorial you can watch. I hope then it will be more easy to understand. Now, last but not least, let's have a look also at equals. So I think for the primitive values here, it's pretty easy because you don't have to use equals. You can just use the not equal operator. So if the bytes are not equal, just looking at the variables without any objects involved, false is returned. And also, see, this is the order I've chosen. I start with the smallest possible values because here checking them is probably faster than doing all this crazy stuff down here. And this is why I've chosen the order. Okay, with a short, int, long, this is all easy. With float, it's a bit more difficult. We have to convert it first to an int. Double has to be converted to a long. Boolean is again easy. Well, actually, if this was a real implementation, I would have done it differently. I would have put it to the top. So this order is also based to explain you the different types. So in reality, I would ask you to really think about the order based on what the business tells you, what is easy to differentiate, and then also you have to think from the performance what takes longer to calculate. Of course, it depends if you really need the performance, and if you do, then always test performance, because you might think something is fast, but when you test it, it turns out it's not as fast as you would have thought. Okay, because what I'm telling you here is just a rule of thumb, but I might be totally wrong in a specific case. So this is also what I'm doing. If I need a certain performance, I test for it. In all other cases, I just do how I feel like it, or I just use my gut feeling to sort the values as I think could be fitting. Okay, so I hope you liked this episode about HashCode and Equals. I'm sorry that this is all so complicated and so long. I just wanted to put in everything possible because this is really such an important topic that you should really understand in detail. Of course, there is way more actually, so I would also ask you, go to my blog, www.markus-biel.com. I will put up some links to some extended articles on the topic. And also you might consider buying Effective Java from Josh Block. He also talks about it quite extensively. So yeah, I think that's pretty much it now. Don't forget to give me a thumbs up in the bottom right corner of this video if you liked it. You can, as always, subscribe to my YouTube channel. And last but not least, if you have a question or want to tell me something, you can leave me a comment. Okay, so thanks for watching and see you next time.